Nowadays, high competitiveness, reduced time to market, and pressure to develop flexible enterprise software, together with the rapid change of technology, have led to the emergence of new approaches to building, deploying, and maintaining software. Several new approaches to software development have been established that may become significant during the lifetime of this course. Model-driven architecture defines an approach whereby business-oriented decisions and specifications can be separated from implementation and platform decisions. The idea is to distinguish between platform-independent models specified using UML and platform-specific models which carry relevant information for the generation of platform-specific code. This approach is based on strong emphasis on models specified in a well-defined notation, transformations between models, formal underpinning of models and transformations, industry-adopted standards and tools. Agile development is an umbrella term used to describe a variety of agile methods that encourage continual realignment of development goals with the needs and expectations of the customer. It represents a compromise between no process and too much process, a lighter weight, faster, and nimbler software development process that can adapt to the inevitable changes in customer requirements. Extreme programming is one of the best-known agile methods. It is a very lightweight method based on intensive testing and incremental development. It defines a series of practices, such as small releases, simple design, testing, programming in pairs, collective ownership, continuous integration, and coding standards. Software developers build models that represent what is important, devoid of unnecessary detail. So, we have models with different perspectives according to the stage of development. We call them domain, specification, and design models. Domain modeling is concerned with understanding and modeling a situation independently of a decision to use a software system to deal with it. A domain model is a representation of the main concepts in the real-world problem, that is, the business under consideration. A domain model does not assume that software is to be used to deal with a situation. Specification modeling assumes that a software system will deal with a situation. A specification model represents software elements used in the software solution to problem and is mainly concerned with the definition, at a high level of abstraction, of the services provided by the software. Design modeling describes the software system, the allocation of responsibilities, and the internal sequencing and control flow. In a simple way, we could consider domain modeling and specification modeling as the analysis activities, that is, concerned with understanding what the problem is and specifying what is required of the software system to be developed. However, we keep the distinction between domain modeling and specification modeling, and use the term analysis for the latter. As you might expect, design modeling corresponds to the design activity. A modeling language defines the notations used for many different techniques. UML is the modeling language that is one of the most popular and successful standards currently adopted by the software industry. UML is the result of the merging of several object-oriented notations that appeared during the 1980s and early 1990s. As such, it is a big language, including many techniques, and even a mechanism to extend the notation. Here, you will not learn UML in its entirety, but concentrate on a subset of the most commonly adopted techniques. UML, being predominantly a diagrammatic language, cannot always precisely specify the complete semantics of a system, and at times must be complemented by the use of natural language, say, English, or by a textual modeling language, the Object-Constrained Language, OCL. In this unit, you will learn to express constraints on UML model precisely using English and OCL. One thing that should be clear is that UML is a modeling language, not a development process. It gives you a set of notations, but it does not prescribe how these notations are to be used. In fact, because UML is the result of an exercise of unification, it can be used with many different processes. It is up to the development process to define how it should be used. Modularity in programming is the idea of breaking a sequential program into named pieces. Eventually, whole design methods came to be based on structuring large pieces of software around their intended actions. Each action was broken into smaller actions repeatedly, down to a unit small enough to understand, write, and test independently. An object-oriented system is a software system whose basic structuring is around things rather than around actions. The usual way computers represent state is by storing values in variables. An object is a set of variables with group of operations that can act on the data. There may be conventions and programming rules to suggest that accessing should be done in only a few places, but these are not enforceable. In an object system, the only operations that are allowed to access the data in an object are the operations attached to that object. Thus, it is guaranteed that no other part of the system can touch the data. When data are entirely hidden behind operations which alone can manipulate them, they are said to be encapsulated. Encapsulation is one of the central concepts of object-oriented technology. A network of objects collaborates to achieve the functionality of the whole system. The figure shows a network of objects representing a hotel, some guests, and some rooms. This sort of diagram is called an object diagram or a snapshot diagram. It shows one particular possible configuration of the system. This particular diagram shows the state of the system when it contains a single hotel, 2 guests, and 2 rooms. The guest with name Jack is linked to the room with name Blue Suite, and the guest with name Jill is linked to the room with name R234. A link is a connection between 2 objects that is significant for the application area. To establish a connection between 2 objects, we need to identify and distinguish between each object. An identity is an unchanging property of an object that distinguishes it from all other objects. Software distinguishes between objects using an internal identity that is intelligible only to the software system. Objects are not distinguished by the data they store. Collaboration occurs when one object requests a service from another object in order to perform some task. To fulfill a particular collaboration, each object takes on a different role. The object that makes the request is called the client, and the object that receives the request is called the server. The request is communicated to the server from the client by message passing. The client sends a message to the server, which on receipt executes the operation with the same name and signature as the message. When the server has completed the execution of its operation, it returns a message answer to the client. Both the message and message answer may convey data between the objects. The signature of the operation is the specification of the type of the arguments and of the result of the operation.